Okay, class, we're going to go over the second part of this work where we are looking at conditions a little bit more closely when we're in sampling distributions for sample proportions. All right, this is specific to a statistic that's a proportion. And so we just looked at a bunch of sampling distributions and saw how that lined up, became less biased and less variable. And we looked at centers talking about mean and standard deviation. We also looked at them as approximately normal. So when we don't have these simulators like we did in number 3 and our previous questions, what do we do to be able to talk about shape, center, and spread? Well, we can verify the shape of a sampling distribution when it's proportions by this test here, this NP greater than or equal to 10. And then the N1 minus P greater than or equal to 10. What is this? This is based on looking at proportions, one, and looking at outcomes that have only two options. Either like you have a proportion that has something and a proportion that doesn't, a proportion, we call it a proportion of success and a proportion of failure. So that first group, NP greater than or equal to 10, is important for looking at this in terms of having a normal distribution. We will be able to verify that the sampling distribution is normal or approximately normal if n times p is greater than or equal to 10 and n1 minus p is greater than or equal to 10. So we do that check to see about the shape. Okay. The next one is looking more toward the center, and that has to do with whether or not it's biased or not. Okay. So how do we know if something's biased or not? Well, a random sample helps to eliminate bias. And if that's the case, our averages, our means of our sample proportions should equal the parameter. And so that's how that happens. All right. And then the spread has another formula involved. That's standard deviation of the sampling distribution. That's this formula here. And we'll see that a little bit more closely further down. But how do we know that we are able to do that formula? It's based on the successes and failures, but our sample that we take has to be independent. We have to know that that if I take that sample, that I won't be changing the population proportion. So it's been determined that if your population is at least 10 times larger than the sample size, it won't really have that much of an impact on the original population proportion when you take out the sample, right? The sample's still small enough, it won't really change what's left. You'll still have the same population proportion. That's important, okay? And we can get into that a lot later, but let's get into our questions here. So what is an SRS? That's number 4 here. What does SRS stand for? So we talk about mean of a sample proportion, or the mean here of our sampling proportions will equal the population. That's an unbiased estimator. Well, we get that by getting what is called a random sample, and SRS stands for simple random sample. So that's important about knowing what those letters mean. All right. Where did we know that came about in this question? Well, if I read through, given the proportion of Reese's Pieces is 0.50, we already knew that. They looked at a randomly selected box of 144 candies. So it didn't say simple random sample, but they used that SRS in there. If it doesn't specify another kind of random sample, it's typically just a simple random sample. All right, let's take a look at number 5 now. So we looked at the fact that to be able to talk about spread using this standard deviation formula, this one here, we would want to know that the population is more than 10 times the size of the sample. We have a sample size of 144 here, right? There's definitely more than 10 times that as a population for Reese's. You're talking about millions and millions of Reese's candies. So that allows us to use this formula. And when I look at this symbol here, this kind of weird looking O with a line on top, and then the p hat, what is that symbol talking about? It is this part, standard deviation. So STDEV for short. And then this part, it's the standard deviation of the sample proportions. So we want to be able to read that symbol and know if that sample size is smaller than 10% of your population, you can use this formula to figure out what the standard deviation is. Now let's go to the last condition, is the shape. And why do I care about the shape? Well, if I know that the shape is normal, we can actually get percentages then. I can actually look at a sample distribution and get percentages from there. So when we do that, we have to have this check of n to p greater than or equal to 10 and n 1 minus p greater than or equal to 10. Those two both have to be checked off for this to be considered normal. And once we get to the fact that it's normal, then I can get proportions out of that distribution, or percentages or probabilities. That's those three P's. So we can solve for proportions now of the distribution. And what am I talking about when we talk about a distribution? It's, this guy here. And notice in this example, this is what we're going to get to, right? We're not going to get there yet, but in this example, we were able to get the proportion of my samples that contained a sample, outcome of 0.48 and 0.52. That was what they were getting at in this question. So that's to come, but we're going to focus at this point on the conditions piece, talking about center, spread, and shape of a sampling distribution. So that's the next part.